All right, let's get started. Good morning and good evening, everyone. Thank you so much for joining. My name is Patrick. I'm one of the lead instructors at hadoopandrealworld.com. And first of all, I would like to thank everyone for joining. And if you don't mind, just type in your name and where are you from. And are you new to Hadoop and Real World, or are you a student of Hadoop and Real World? How do you know us, and how well you know us? Just type in the chat, and then we'll go from there. Okay, we have Keval from India. We have Aditya is new to Hadoop and Real World, but is from US, Kansas City. Naga from Kansas City, US. Binoy from India. Devraj from Dallas. And we have people familiar with Hadoop and Real World. And Shobha from New Jersey. From Madison, Wisconsin. We are close. We are from Chicago, so we are very close. Bashir, US is a Hadoop architect. We have Mukesh from Kolkata, India. I know Hadoop and Real World, and I follow your post. Perfect. Perfect. Thank you, guys. Thank you. All right. For those of you guys who don't know us, we are a group of Hadoop consultants, and we have courses on Hadoop. We specialize in Hadoop, and we have courses on Hadoop, right? Overall, we have about 65,000 students across all our courses, okay? So we have 4 courses now, and the 2 courses are free, and we have 2 more courses which goes in depth in Hadoop Developer and Hadoop Administrator. And towards the end of this session, I'm going to give you a discount to get both of those courses as a bundle, okay? And we have 2 more free courses too. So we have a free course on Hadoop and a free course on Spark named Hadoop Starter Kit and Spark Starter Kit. They're completely free. You can go to our website, courses.hadoopandrealworld.com, and you can start enrolling as we speak. Okay, so you don't even have to wait. You can just go ahead and enroll in our free courses like right now. Okay, and we have 2 other courses which goes into developer and administrator topics in depth. Sounds good? Okay, and as I said, we have about 65,000 students and plus. It is growing, all right? So for those of you who are very new to us, I just wanted to give a quick a shout on how we are different from others, okay? People ask us these questions. When students want to work with us or want to learn from us, they will be like, how are you different from others? Because I see a lot of people teaching Hadoop, so how are you different from others? And we say, check out our free courses, okay? Our free courses are better than others' paid courses, right? And we say that with confidence and pride. We take our time in putting our courses out, and they are of excellent quality, right? So as I said, join our free courses. One of the free courses, or both of them, Hadoop Starter Kit and Spark Starter Kit. Go to courses.hadoopandrealworld.com, and you can start learning today. Okay, the second differentiator, and which is a big one, which is we focus on big data and big data only. We don't focus on any other streams or any other technology streams. Okay, we are experts in big data because we do consulting. Even now we do consulting, right? Consulting to live clients, and we focus on the expertise that we have, which is big data, Hadoop, Spark, and NoSQL databases and things like that, right? You would see other places too in Android, iOS, cloud technologies, along with big data technologies like Hadoop and Spark. We don't do that. We focus on big data, and that's our specialty, right? So doing so, that gives us enormous focus. So when we put out our courses, even when we come out with a blog post, we are very extensive in coverage, and the quality is much better. Plus, we want to support our students much better. Okay, so we don't want to like outsource the support functionality, and all our support is in-house. And usually the instructors are the people who are putting together the courses are the ones who are responding to your questions. and we are pretty quick. Okay? All right. So this is how it's going to work today. First, we're going to go over the questions that you asked us in the past couple of weeks. So we sent out we put out a Facebook post asking us to ask us questions that we can answer in the webinar today. So that is exactly what we're going to do. So you ask the questions and we're going to answer. All the questions you're seeing here today that are getting answered, they were asked in our Facebook post, or some came through the emails. Okay? Sounds good? All right, let's get started. Okay, so here's our first question. In MapReduce documentation, it is mentioned that in ideal case normally, the number of reducer is 0.95 or 1.75 multiple by number of nodes times MapReduce. How to find when to multiply 0.95 and when to multiply with 1.75? Okay, first of all, the question here, let me explain the question first, okay? The question here is basically how do I determine the number of reducers I need for my MapReduce job? That is the simple question here, okay? And the documentation that is being referenced here, first of all, it's very old, and second of all, it's incorrect, okay? And this is not a documentation, by the way. This is a wiki page entry when Hadoop went live like years ago, okay? And the terminologies that are mentioned here, especially, they're talking about number of nodes, and if you go to the old wiki, the wiki page, it will talk about task tracker, job tracker, and all that. Those are all terminologies used in Hadoop version 1. And those are all concepts from Hadoop version 1. And Hadoop has grown a lot since then, okay? And also this code is wrong. It's because it assumes that you have only one job running in your Hadoop cluster, which is usually not the case. So first of all, it's from an old wiki page, which is not relevant anymore, and the post is still wrong, okay? But still, let's answer the question, how do we decide on the number of reducers? Because I think that's going to be a helpful answer, right? So how do we know the needed number of mappers? It's very simple, right? So if you have gone through the MapReduce chapter in one of our courses, you would know that the number of mappers roughly equals to the number of blocks in HDFS that you're trying to process, okay? So that's a simple calculation. You don't have to think about it a lot. All right, but let's talk about number of reducers. Number of reducers by default is usually 1. Okay, by default it is usually 1. Okay, so what is the problem with that? Let's say you have 1,000 mappers, right? And 1,000 mappers sending key value pairs to one reducer, and this could be problematic because you're getting data from 1,000 different sources, but you have only one reducer to process the data. Not an ideal situation, right? Because your reducer can run very slow and eventually complete, or it could not take up the load and it might break, right? So you don't want both, right? Or there could be another scenario where you still have 1,000 mappers, but let's say each mapper is sending out one key value pair, just for example, right? One key value pair. Then you have 1,000 key value pairs sending to one reducer, being sent to one reducer, which is not bad, by the way, right? There's just 1,000 key value pairs for one reducer. Your reducer will finish in no time. So you can see both sides. You can see both extremes, correct? So for this reason, it's not easy to say, use this formula to decide the number of reducers. It is not easy to say, right? It has to be based on per job basis. Each job is different. Each requirement is different. So it has to be on the per job basis. There are 3 things you need to consider here, okay? When you decide on the number of reducers. The first is, your reducer should successfully execute, meaning we are hoping for successful executions of your reducer. And the second thing is your reducer should complete in decent amount of time, meaning you don't want your reducer to run forever, which is bad, right? And the third thing is you want fewer files, right? You want fewer files. If you have 5 reducer, you would end up with 5 files. And why this is a big deal, Why do we need to care about number of files, right? Let's say you have 100 reducers, okay? And which will result in 100 files. And we know Hadoop, we know Hadoop is not good with small files, right? Because the block size in HDFS is 64 MB or 128 MB, right? And even more. You can even set to 256 MB. It's configurable, right? So Hadoop doesn't work efficiently with smaller files. So if you have more number of reducers, which means you will end up with more number of files, and each file could be potentially smaller, right? You don't want that in your HDFS. So keep this in mind. Keep the three things in mind. You want successful executions, which means if you are sending a lot of stuff to one reducer, you may want to think about spawning multiple reducers. And it is configurable. When you kick off a MapReduce job, you can say, I want this number of reducers. And the second thing is you want your job to be completing quickly, right? You have 100 mappers. 100 mappers may complete in 5 minutes. Your reducer should complete in like few minutes, not like 20, half an hour, right? So you want to keep that in mind. Next is fewer number of files. Also keep in mind, if your reducer is struggling, right, you don't have to immediately spawn another reducer or execute the job with more than one reducer. Think whether you can optimize the reducer program. What is the reducer doing? Is it using a lot of memory, and hence it is hence it is slow, or it is just it is handling a lot of data, right? Also, with MRV2, you can increase the amount of memory that is given to the reducer. Okay, so you can increase it. If a current reducer is using 2 GB, let's say, and it is very slow, and you're hitting memory thresholds, you can increase it to 4 GB. And maybe with just one reducer, it can complete faster now with more memory. Okay, so keep those in mind when you think about number of reducers. All right. Okay, so let's move on to the next question. Okay. So how to capture or land source data to Hadoop when source is a flat file and each record in the source file has a dynamic schema, meaning the number of columns and data changes for every record. We got this in an email, right? We got this question in an email. So what is the question here? How does Hadoop works when my file or my data set has multiple records and potentially each record could be of a different schema? Okay, it's an interesting question, by the way. So let's talk about an example. Okay, let's take Hive table, for instance, and assume Hive table has 3 columns, right? Hive table have 3 columns, and your Hive table has 3 records, right? Your Hive table has 3 records. And the first record has, let's say, 3 columns. It aligns with the number of columns in the Hive table. And the second record has just 1 column. Your Hive table has 3 columns, but the second record in your table has only 1 column. And the third record has 4 columns. Okay? So let's talk about the first record. The first record has 3 columns. It aligns with the number of columns in the Hive table. So when you do a select, it is simple, right? It selects, your 3 columns get assigned properly with the rows, and then, your selection is fine. Now let's talk about the second row. The second row has only 1 column, whereas the Hive table has 3 columns. Even now, Hive will still work okay, because if you think about like Oracle or SQL Server, you can have nullable columns. So in this case, Hive will consider the second and the third column being null. Okay. Now the interesting thing is when you encounter the third record with 4 columns. Okay. So if you compare this with Oracle or SQL Server, this scenario is not possible because the schema is enforced when you insert anything into the table. So you cannot insert a record with 4 columns to a table with 3 columns because the schema is enforced at insert. Or in other words, traditional RDBMS enforces schema on write. Okay? Whereas Hadoop and other big data solutions enforces schema during read. And this is a big plus, right? Which means our data can be very flexible and fluid. And even when in cases when our data is wrong, Hadoop and tools like Hive are forgiving of those errors. Because in a big data environment, when you're getting data from multiple sources, it is not always easy to control the quality of the data. You need to put process and procedures in place. right? It is more common than you think to have invalid data coming into HDFS. So Hive basically picks up the 3 columns and ignore the 4th column in this case, right? Because Hive enforces schema on read, and it is also very forgiving. It doesn't error out. It will just pick up the first 3 columns, map it to the columns in the table, and then just ignore the 4th column. Okay? Excuse me. So that is one part of the equation, right? So how the schema is enforced in big data tools and Hadoop in general. The next is the rows with completely different format. You know, what would you do if you have a file and your first record is CSV and your second record is JSON, you know, and your third record is something else, right? Which means your file itself has multiple formats. The data itself in the file has multiple formats, and this is bad, right? And this is bad. Your tool cannot cope up with this. When you define a Hive table, for instance, you have to say what kind of format, you know, Hive should expect the data to be in the file. And if you have a conflicting formats, Hive cannot handle it, and you would see errors. So in that case, the only way to resolve the solution is to put a cleansing process in place. So when you ingest the data from another system, it could be Scoop, or it could be Flume, or it could be streaming service like Kafka, right? You need to cleanse the data before you load it or before you attempt to work with data with any of the tools, let it be Pig, Hive, or whatever, okay? So there are 2 things here, 2 things to understand. Hive and tools in the big data framework are very forgiving of your mistakes. Okay, in case you have more columns, nullable, non-nullable columns, it is forgiving. But on the other hand, you need to also make sure the formats align with what is defined with the tables or in the tool set. Okay, so you cannot define a Hive table and make it as to read CSV, to work with CSV, and ingest a JSON file and expect Hive to work, and that's not going to work in any tool for that matter. Okay. All right. So I'm going to go through the questions first, and then I'll stop and I'll ask. I'll wait for your questions to come in if you guys have any questions. Okay. So I'll go through the questions that came in first, and then you will have a chance to ask questions, and hopefully we'll be able to answer them. All right. Next question. Vectorized query execution. What is vectorized query execution? Okay, so in a standard, again, Hive table, let's take Hive as an example because this is very specific to Hive. In a standard execution, when you have a Hive table and when you do a select or any kind of operation on the table, the standard execution plan is the records of validator are evaluated one by one at a time. So 1 row at a time. So the first row is read, the first row is mapped with the data types, and then Hive will read the data and process column by column. So that's a standard execution procedure, right? The problem with that is it is not highly efficient, especially when you have a lot of columns to process, and each column could be of a different type. Your CPU takes a hit. This is how almost all tools work, but there is an efficient way to do this. It's called vectorization, right? The concept of vectorization, 1024 rows at a time are grouped together, right? So your data is organized into 1024 rows at a time, and the columns are grouped together as well. The column values for each column are grouped together. And so any kind of aggregation or anything that you can do can be much faster, right? So if you joined our last webinar where we talked about RC file and ARC, this concept might be sounding very familiar to you. It's a row columnar format, right? Precisely, it is exactly that. It is exactly that. So vectorized query execution, it is possible with Hive only with ARC format. Okay, so keep that in mind. It is possible only with ARC format. So if you're not familiar with ARC or ORC file format, check out our blog or our YouTube channel, because we have the recording from our last webinar there. Okay. All right. And the last thing to note is vectorization or vectorized query execution is only supported on primitive column types, right? Meaning like integer, small and big int, float, that kind of stuff. It is not supported for complex types such as struct, map, etc. Okay? All right, cool. So moving on. Okay. This is an interesting question. The next couple of questions are related to tools in the big data ecosystem, okay? What is the real-life use of Apache Spark for ETL type workloads? That's the question. Okay. So for those who are not familiar or not from the database background or from the big data background, ETL is extract, transform, and load. Okay, so extract, transform, and load. You're extracting the data, meaning you could be reading the data from somewhere. You will be transforming the data. In other words, you'll be massaging the data, and then you will load the data into the destination in the required format. So that is a process. It's basically reading, cleansing, transforming, loading. Okay. So now let's talk about a very simple use case. You know, in our course, we use the data set called stocks data set, right? And we do aggregation on the stocks data set. You know, for example, let's say you wanted to aggregate by symbol and find out the average volume by symbol, right? It could be a very simple ETL operation. You have all the stocks records coming in for multiple days, multiple months, multiple years, whatever. And you read the data, you transform the data, do whatever operations, do cleansing and all that, and then you aggregate the data, you load the data into your system, right? And then you can have tools, visualization tools like Tableau or business objects to look at the data for visualization, right? So Hadoop, we know Hadoop works, can work with that, right? Can work with ETL, can be a substitute or can do ETL type operations, you know? Can Spark do ETL type operations? Of course Spark can do ETL type operations, right? Spark can do the same use case. You know, it can take the stock data set, it can read the stocks data set, and it can basically calculate the average volume and load the average volume into the final destination. Spark can do that, right? But Spark's strength is iterative processing, okay? So you iterate through the data multiple times. That's what the strength of Spark is. So you go over the data and you hold the intermediate data in memory. So for those of you who have taken the Hadoop in Real World course, we covered a project to compute the page ranking of multiple pages from Wikipedia, right? So basically what we do is we have a MapReduce job which loops over the data, right? Which loops over the data, and it basically saves the data in HDFS. And then you run the same MapReduce process again multiple times. You iterate over the output multiple times. It's one example of iterative processing, right? The problem with that approach is that each time when you read the data, you have to read it from HDFS, meaning you have to read it from disk. And imagine you're reading a terabyte of data every time you execute a MapReduce job, your process is going to be very slow, okay? So Spark, and there are a lot of use cases which requires iterative processing, like the one we just saw about, like similar to page ranking, okay? So Spark came up with a solution. Instead of storing the intermediate data in disk, it holds it in memory, right? So the iterative, the repeated processing, the processing after that is much faster because the data gets processed from memory instead of processed from disk. Okay, so that is Spark's specialty, right? You can obviously use Spark for ETL kind of operation, right? But Spark's specialty is to work with iterative algorithms or iterative processing, right? Makes sense, right? And also you will see Spark being used in a lot of real-time systems, real-time streaming systems. You know, Spark has a functionality called real-time streaming, where it can take the data as it flows through and it passes the data in batches into Spark's execution engine and calculate or do manipulation the way you want it, right? And this will happen real time using Spark streaming. Spark also has libraries for machine learning, MLlib, graphics algorithms, and things like that, right? You can certainly use Spark for ETL type operation, but in production environments, you will most likely see Spark being used for a lot of analysis-based queries and iterative processing, and also for streaming. Okay. So that's one of the main benefit of Spark. All right. Now moving on. Another question related to framework. Okay. How Apache Flink changes the current scenario, and what is the use of that in big data? Again, a very interesting question. Okay. What is Flink? So to talk about Flink, we can compare Flink with Spark, right? Both tools came about a year apart, I would say. The first release the first release for both Flink and Spark came, like a year apart, right? And both are processing frameworks. Spark has an execution engine. Similarly, Flink also has an execution engine, right? Both focuses on faster execution. Both focuses on distributed, faster execution. Both frameworks, both Flink and Spark, they don't come with a storage component, right? Because both tools, the idea behind both tools is to leverage the existing storage components like HDFS or S3, or it could be a NoSQL database, so on and so forth, right? Both Flink and Spark support streaming applications. They both support machine learning. They both support iterative processing. They both are cluster agnostic, meaning you can run Spark on Yarn, same thing. You can run Spark, you can run Flink on Yarn or Mesos. It's another, Mesos is another resource manager like Yarn. You can run both Flink and Spark as standalone. So they both are deployment agnostic. You can deploy it in multiple different ways, right? So, how Flink is compared to Spark, right? The difference between Flink and Spark is the way the computation engine is implemented. Spark relies more on RDD, an abstract concept called RDD. It's basically an abstraction of your data set. Flink, on the other hand, heavily relies on chaining, reusing of data, and algorithmic technique changes and things like that for its efficiency. So the implementation of the engine is widely different, okay? But they both are aimed at improving the computational speed and iterative processing, okay? And how Flink coming into the big data ecosystem changes big data, or the big data, the way people use these tools, we have to wait and see, right? There are always tools coming in. There are always new tools coming into the market, right? There are always new tools coming into the market. Hadoop was widely popular, then came Spark. Spark, everyone thought, okay, Hadoop is gone. Spark is going to replace Hadoop. Hadoop has some very strong components, which Spark didn't really target it to replace, so like HDFS and things like that. So you can see like Hadoop and Spark coexisting on the same, even on the same cluster, right? Similarly with Flink, we need to see how it's going to turn out. But just pure comparison of usage and the user base, Spark has a wide acceptance, right? In terms of iterative processing and faster execution, Spark has a wider acceptance than Flink, okay? It might change, it may not change. We have to wait and watch, all right? There was one big disadvantage. This was back in, I guess, 2015 maybe. Spark would crash if it cannot hold the RDD in memory. Okay, so if the RDD gets too big, Spark could eventually crash. But Flink was able to support bigger data sets, even when memory cannot, even when you don't have enough memory to hold it. And the reason, and the way Flink implemented that is through swapping the data to the disk from memory, like disk swapping, right? But Spark introduced a project called Tungsten, and they took care of the issue, starting 1.5, I believe, starting the release 1.5. So that's not a problem anymore, okay? So anytime you see deficiencies coming in the system, these are open source products, right? So people jump in, and people who are interested in the product, they jump in and they take the product to the next level, apply necessary bug fixes, necessary enhancements to keep the product up to date. So it's going to be interesting, but for now we see wide acceptance for Spark when compared to Flink. Okay, all right. Okay, before we move on to the next questions, let me stop here and let me take some of the questions from the audience here. Okay. Yeah, you can go ahead and type your questions. I'll also see whether there are any questions that I missed just now. Okay. What is the difference between Flume, Spark streaming, Kafka, and structured streaming? How to size the cluster? Okay. 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 So let's talk about Flume. Okay. So Flume is very limited. When streaming applications are meant to stream the data in real time, right? So you take the data, you stream it to your destination. It could be HDFS, or it could be to an execution engine where you process the live streaming data and compute the result that you want. Okay, so Flume is very old. First of all, it's very old, and it was meant to stream or move like log messages from different nodes to a centralized location. That was the initial use case for Flume. Okay, that was a very initial use case for Flume. I think even if you go to Flume's homepage, that's what it would say. It's a log aggregator. That's the original vision for Flume. And later, they added a lot more things to it, like integration with other tools like Hive, integration with even Kafka and things like that, just to keep the tool afloat. All right. So Flume is not widely scalable and distributed when compared to Kafka, for example. Well, Kafka is an interesting tool. Actually, as a matter of fact, the latest update that we are working on for Hadoop in real world is Apache Kafka. So Apache Kafka will be available, will be added to Hadoop in real world course by end of the month. Going back, so Apache Kafka is a highly scalable distributed streaming framework. So you can stream data, for example, from Twitter or from, let's say, Meetup or from Uber, whatever, right? You can stream data from multiple sources into your Kafka cluster, and you can have multiple consumers consuming the data. Okay, so you have multiple sources pushing the data to your Kafka cluster, and you can have multiple consumers reading the data. Okay, I know some of you who are familiar with enterprise Java, messaging applications and things like that, you're thinking this is already available, right? This is already available with messaging. We have RabbitMQ, we have WebLogic, we have WebSphere messaging, TIBCO, whatever, right? How is this different? How Kafka is different? Well, Kafka is designed ground up to work with, we're talking about throughputs of billions, right? So it is designed to work with hundreds and thousands of nodes, scalable and also fault tolerant at the same time. Okay, so we're talking about scalability and also being fault tolerant at the same time, a much faster throughput. We're talking about messages in billions. Okay, we're not talking about millions, we're talking about billions. High throughput, very low latency, that's the game here. So with Kafka, a consumer can push messages to the cluster, right? And your messages gets replicated. So if someone who is consuming the message, goes down, your message is still available for the consumers to read. Okay? So if a producer is going down, of course, no messages comes in. But if the node which is holding the messages goes down, your consumers can still get the message from another node. So meaning the messages are in Kafka's terminology, the partitions are replicated. In Kafka's architecture, we call it broker, we call producers and consumers. I can't go much deeper into the architecture now, but in Kafka's terminology, you have a topic. I'll touch on it a little bit. It will be interesting for you guys, right? So in Kafka's terminology, you have what we call a topic, right? Producer, that is, it could be Twitter as a producer, let's say, or Uber is a producer, or meetup.com is a producer. They're pushing messages, let's say, to you, and you're ready to consume those messages, right? They're pushing the messages to a topic, and the topic resides in a Kafka cluster in multiple nodes, right? So each message is assigned to a partition, and each partition is replicated to multiple nodes. Got it? So now your consumers are consuming the messages in the partition, and if one of the broker who's dealing with the partition goes down, your consumers can go to another broker, another replicated broker, or another replicated partition and get the messages. That's Kafka, right? Spark streaming, on the other hand, it's another interesting concept. Spark can get messages from Kafka, right? And as the messages are coming in, it can basically do live computation in batches, in data chunks, right? As messages coming in. So far when we talk about reading the data from HDFS, we are talking about data that is already in HDFS, right? Now we are talking about, with Spark streaming, you can basically fetch the data from Kafka. Now Kafka will be the source, right? And someone else is feeding Kafka. So Twitter stream is feeding Kafka, and Spark streaming is now consuming the messages out of Kafka, and it is basically and divides the stream into chunks, and Spark's execution engine executes the data as chunks as they come in, whatever execution that you want to do, right? So those are the different options that are available, right? So we talked about Flume, which is at this point it's legacy, and now we have Kafka. And we have Spark streaming to support things like coming out of Kafka. So you can think of Kafka as a producer in this case when it comes to Spark streaming, because Spark streaming is going to consume messages from Kafka, divide the messages into chunks, and then do its own execution. Okay? All right. Okay, so how to size the cluster? Interesting question. Actually, we have a separate chapter on sizing cluster in our administrator course, right? But let's go over some of the basics here. The first thing is sizing a cluster based on size. It's very, very easy. If you want to decide on the number of on your disk space, it's very easy. Okay. Why? Because you can at least, hopefully, you have a better view of your data volume coming in and the growth of your data, your projection of your data growth. So with these two parameters, you can easily say, how much disk space you need in your cluster, right? So that's the disk space. You could say like my cluster is going to support 40 terabytes of data, right? So if you add replication factor to it, so if you're going to replicate 40 terabyte 3 times, you need 120 terabyte, right? Plus you need space for your OS, you need space for your logs, you need space for your other installations, other packages, and things like that. So you need to account for all that. So if you account like 20%, you can do the math and you can come up with a number, right? So the next difficult thing to do. Actually, this is a difficult thing to do. The storage is easy. The computation is difficult. And I'll tell you why this is difficult, right? Because it's, practically, if you think about it, let's say you're a company and your manager or your strategy team is coming up and saying, we need to implement Hadoop for a couple of use cases. We have a couple of use cases. We cannot implement or get the same results from the existing solutions. We have to implement this in Hadoop. And you look at the use case and you say, wow, okay, so Hadoop can really solve this. I'm going to implement this in Hadoop, right? So now when you think of the computation and how much capacity you need, you are limited to those two use cases. Realistically speaking, you cannot visualize at this point in time. You can possibly visualize few other test cases, but you really don't know how are you going to use the cluster in 2 years down the lane or 3 years down the lane, right? You may start with Hadoop and end with Spark and Kafka and Kafka, Spark streaming, right? So you can start somewhere and end somewhere. But when you're sizing the cluster with just 2 use cases or handful of use cases, it's really hard to get an accurate sizing. Okay. So now to size the cluster with computation is difficult, but you can do some projections again, right? You can see like how many jobs are going to run in peak time. That's the visualization that you have to do, and you have to talk to the business a lot to get a lot of their inputs, right? So let's say you're going to execute like 100 jobs during your nightly processing, let's say, right? 100 jobs during a nightly processing in 3 hours time span, right? And these 100 jobs is going to span, like each one is going to span 100 mappers. And each mapper is going to take 2 GB of memory, right? And each job is going to spawn 2 reducers, for instance, right? So 100 jobs, each spawning 100 mappers, that's what, 1,000, right? Sorry, 10,000. And then you have 2 reducers each, which is 200 reducers. Now multiply, the number of mappers you have times the number of, the amount of memory you need for each, right? Each mapper. It could be 2 GB. You can configure it per job, right? So you can say 2 GB or 4 GB for mapper, or even 8 GB per mapper, right? Same for reducer. You can configure 4 GB for reducer, 8 GB per reducer, whatever, right? Now you can get an idea of how much memory do you need in that in those consecutive execution time span of 3 hours, right? Then you can size your cluster accordingly. Then you can divide, then you can decide on the number of nodes. The storage, how much storage you need for the next 2 years or 3 years. So you can size your storage according to that. Now you know the memory for your peak times. It's not going to be accurate in the next 2 years, realistically speaking, but at least you have somewhere to start with, right? And then you go ahead and now you know the amount of disk space, amount of memory. Now you can talk about number of nodes, right? So you need to think about the number of nodes for a second here, right? Do you want to have, so if you want to hold, let's say, like 100 terabyte, do you have 100 nodes with 1 terabyte each, right? Or 50 nodes with 2 terabytes each? How do you do it, right? You can go for beefier systems, right? And this is beneficial in the long run, right? The reason is, when you go for like beefier systems, you will end up with less number of systems, less number of hosts to deal with, which means less possibility for failure, right? At the same time, you need to have fault tolerance. You don't want like to run your Hadoop cluster on 2 nodes, right? I mean, that goes without saying. It defeats the purpose of Hadoop. But at the same time, you want to have beefier or bigger systems with more disk and more CPU so that you can have less number of nodes. And the reason is, when you have less number of nodes, you have very limited options for failure, right? Fewer failures. You will have fewer failures. Plus, in a data center, where real estate is getting expensive, you're using very less rack space, right? Which means you're using less power. Your cooling systems are much more cost efficient. You see what I mean? So you have to think, you have to take all those into consideration. So a lot of things go in play. A lot of planning needs to be done. Think of this to summarize. Think of the storage first, then think of the computation. The nice way to think of computation is during your peak times, how much memory do you need for like consecutive executions of, let's say, 100 jobs, right? And then divide it into number of nodes. And when you decide on the number of nodes, have your systems beefier than slimmer, right? Have beefier heavy systems and less number of nodes. But at the same time, keep in mind, the system's Hadoop has to be fault tolerant, and it is fault tolerant when you have multiple nodes. So there's no point running Hadoop in like a 3-node cluster, okay? All right. Could you please talk about data locality? Okay, so let's talk about data locality. Data locality from the Hadoop point of view is basically you have your data in HDFS, right? You have mapper running against a block, right? And let's say the block that you need is on the same node where the mapper is executing, which means the data is local, right? And the benefit of that is your computation will be faster because you don't have to bring the data from anywhere else. The data is local on the node itself, right? So that is being data locality. That's how you want it. That's the most efficient way to do it. But what happens in a busy cluster, it is not always possible to launch a mapper on the same node where the block resides or where the data resides. So what you do, you launch the mapper in another node, and you bring the data to the mapper. You copy the data over the network to the mapper. Again, sometimes you would have to do this, right? Sometimes you would have to do this. There is no other way around it. Sometimes you would have to do this, but the problem is you're taking an efficiency hit, right? A hit for your efficiency, because now you're consuming the network, that is one, and also your job has to wait for the data to come in, right? So those are the two big disadvantages, right, with data not being local. All right. Okay. All right. I think we have we answered a lot of questions here. So that is good. So I've also saw a question about cluster access. I'm going to answer that in a bit. But we got 2 more questions from our Facebook post. And the questions are, what are the prerequisites to become a Hadoop dev/admin? And a similar question, what are the prerequisites to become a tester in big data? Okay, so let's talk about dev first and then admin. Okay, so Hadoop ecosystem is wide. As you can see, there are a lot of tools, and there are always a lot of tools coming up. It's like the Apache incubating is super hot always. There is always new tools in development, or they're getting their stable releases every week almost, right? So you will see developers in the real Hadoop developer space. You will see developers with multiple capacities, right? You will see from multiple streams, with different backgrounds, right? You will see SQL developers because someone who was like an Oracle developer or a SQL developer, PL SQL developer, they know data very well. They know how to work with data, so they transition into the big data or Hadoop world, right? So you will see people with SQL background. You will also see people with Java background. You will also see people with Python background. There's no limitation. You see people programming in SQL, Scala, things like that, right? And you will also see, obviously, architects and people like that, right? So who design the cluster, strategy, and things like that. So it is a diverse culture. It is a diverse environment. So, some of the basics are like SQL. Those are the, prerequisites, right? You should be able to write SQL, which is very easy to learn, even when you're not very familiar with SQL, it's very easy to learn. You can also look at, we should also know Linux commands because you will be working in Linux systems. So you need to be familiar with Linux, the operating systems, the commands, the basic commands, to an extent where you can troubleshoot the process, look at the logs, kick off a service, things like that. Okay. From the admin standpoint, again, we have seen people transitioning from system engineers transitioning into Hadoop administrators, people working from business intelligence like business objects, Tableau, working in actually Hadoop developer or administrators. Or also you will see a lot of system admins transitioning into Hadoop administration. Okay, Again, you will see different, different culture there, But I think the prerequisite there is you need to be familiar with Linux. Since you're going to do administration, you need to have some Linux background, at least the basic commands, how to troubleshoot a process, how to check memory, how to check CPU, and things like that, right? And there is also like another angle of DevOps where some person is working on both sides, right? On both on the developer and also on the operation side. He develops things, he understands the development background, and also he's able to deploy things into the cluster. He has also has limited administration background, things like that, right? But any stream you choose, either it could be a developer or it could be an administrator, you need to be you need to have core concepts down, right? You need to know what is HDFS, for instance, what is MapReduce, for instance. You should be able to work with Hive, right? You should know what is the architecture of HDFS, how the MapReduce paradigm works. So the basic concepts, you should be strong in those concepts. I think that's very important, right? It doesn't matter whether you're an administrator or a developer. You need to be strong in those concepts. You should be able to execute a Hive query, access HDFS and things like that. You should know the architecture too. The architecture is not only for the administrators, but also for the developers. When you know the architecture, you can build efficient applications, right? So that's for dev and admin. Now let's talk about testing, right? Again, you need to be strong in concepts, right? You need to have familiarity with tools, slightly more than the administrators. The reason is, let's say your developer team is creating a new workflow where they're bringing in data from a database using Scoop, and they're pushing it to HDFS. You should be able to see, how the flow works. So you may have to go and investigate a Scoop job. It could be a Scoop incremental job. You may have to examine a Scoop job. You may have to see like how a Uzi flow worked, so you should know how things flow. So if you're doing performance-related testing, you should know, what a mapper is, what a reducer is, where the job is stuck. You need to know where to look at things, You should be able to access HDFS. So you need to be a little bit hands-on, with the framework or with the platform, right? So there are different, so if you are developing a use case and your day-to-day operations will be more like your development team is putting together a workflow and you're testing different scenarios on the workflow, and you're comparing what is the input and what is the expected output, things like that. You'll be doing some performance testing as well. So when a job is stuck, you should be able to talk to the development team saying that, hey, this job for this input, it is getting stuck in the reduce phase for at 75%. Take a look, right? You don't want to just say that, hey, I don't see an output, right? You want to dig a little bit further, right? So what are the prerequisites for testers? Most testers are familiar with SQL. Even if they're not familiar with SQL, it is easy to learn in our opinion, because you're doing selects, inserts, things like that. Although you may not be writing queries all the time, it's nice to know. Some Linux knowledge is definitely needed, because you'll be working in Linux systems. You'll be accessing HDFS, things like that. Commands, basic HDFS commands, basic yarn commands are very helpful. Okay, and if you're working on a specific tool, based on the tool you work on, you need to have some background on the tool. Okay, so if you're working on Scoop, you need to know what is Scoop. If you're working on Hive, you need to know what is Hive, right? You could be testing a Scoop job. As I said, a Scoop job can bring the data from the table, so you could be testing that. So you need to know that, right? So those are the prerequisites, I think, and those are the roles of Hadoop developers and administrators. And this is where we can really help. Okay, so in our courses, I said we have two courses, Hadoop Developer in Real World and Hadoop Administrator in Real World, which goes in depth into all these concepts, right? So everything that you need to be confident in your day-to-day jobs to handle production clusters, right? So we know what is we know what is needed in a production environment, so we have designed the courses accordingly, because as I said, we do consulting still, we do live consulting we have consulting engagements with our clients, right? So we know what is out there, we know what are the difficulties developers face, we know what are the difficulties administrators face. So we have taken those concepts, those knowledge, and we have integrated into our courses. So these are live video courses, not live, I'm sorry. These are step-by-step, well-organized video-based lessons, right? And someone was asking about cluster access. Yes, you will get cluster access to a 3-node Hadoop cluster hosted on AWS when you sign up for the courses. It's your personalized account, meaning like no one else will have access to that account. When you sign up for Hadoop Developer or Hadoop Administrator in real-world courses, you can access HDFS, you can kick off MapReduce job, you can do big commands, Hive scripts, Flume, Scoop, things like that. And you don't need any heavy hardware or a new laptop for this. All you need is like a small little tool called Putty, and you would be able to connect to our cloud in like 2 minutes, okay? And you can try your first HDFS commands or MapReduce commands. It's a lifetime access to both courses and also for the cluster. We do update our courses regularly, as I said, because we focus on big data and big data only, so we take a lot of time in updating our courses. Okay, so we do update our courses regularly. So last month we came out with file formats, last month we came out with troubleshooting for the administration course. The month before that we came out with file formats where we covered RC file, ARC, and Parquet. And this month we'll be covering Kafka, Apache Kafka, and this update will go into our Hadoop Developer course, right? So you'd get regular updates and you get lifetime access to the course, and all the updates that gets pushed to the courses, you will get it as well, okay? So now, I want to share a couple of reviews. We always love to hear feedback from our students. These are our recent reviews for our courses. The first one is really nice. It's one of the best Hadoop courses I've ever taken. I have some interviews lined up, so I'll be going over these resources again. So this is very important. So for the Hadoop Developer and Administrator course, we also talk about interviews as well. So what are some of the common questions you will be asked in interviews? What are some of the real world scenarios you'll be facing or you'll be asked in interviews? We talk about that as well in our courses. So the next review is, I decided to take Hadoop Developer and Real World course because Hadoop Starter Kit was great. And again, Hadoop Starter Kit is a free course, by the way. Concept explained very well and usually accompanied with a good visual. And the last part here says, I configured my own Hadoop cluster in AWS using the course instruction and use Big Hive to analyze the data. This is important because we do everything on the cloud, right? Because we want to see or we want you to experience what you will be asked to do in a real world setup, right? So that's why we use a lot of installation, configuration in the cloud. We do both like customized configuration, like manual setup, step-by-step setup. And we also show like Cloudera, how do you do with Cloudera install and configure a cluster with Cloudera or Hortonworks, right? So it's always nice to hear from our students. We just wanted to quickly share a couple of feedbacks from our students. And again, thank you so much. All right, if you have any questions, don't hesitate to ask. Send us an email, info@hadoopinrealworld.com, okay? And guys, thank you so much for joining us. It's always a blast when we come online. I hope you guys learned something this past hour. I had so much fun sharing the knowledge with you guys. Until next time, see you and bye.